Hello everyone, hope you all are doing fine. I am Saptarshi Mukherjee. I am a software engineer 3 at Google. I have been a computer programmer from over quite a long time. So yeah, we are at the last video of our playlist, and this is on the best problem in the playlist in this Leetcode Biweekly contest 123. The problem, as you see, it is mentioned with difficulty hard, but as I mentioned before, this is a medium difficulty level problem. You just have to hit the right pieces, that too not from the air, but through logic, through basic logic. No fancy algorithm, no fancy data structure, and you can easily land up to a very simple code. I'll show you the code also at the end. So okay, let's get started. But before we get started, if you have not liked and subscribed, please do like and subscribe. Please share in the comments how you are feeling, or if you have any doubts or any other thing that you want to share. And please share with folks who might find it interesting. There is a lot of hard work that goes in actually curating these videos and then presenting in a beginner friendly way. So make sure you are providing the necessary support. Okay, so let's get started. The question says that you have n points on a 2D plane. This is your 2D plane, and among you have to basically place n people, including Chisato and Takina, and you have to place them in such a way that Chisato wants this. They want to be at the upper left corner. Takina want to be at the lower right corner, which means they want to build such a rectangular fence that Chasita wants to occupy the top left corner, and Takina wants to occupy, or Chisato wants Takina to occupy their bottom right corner, and in such a way that in that rectangle that is formed between them, there is nobody else. So let us see what this question means. Let's say we have few points. What Chisato Takina wants is that, let's say we have this point, and this point. If we place Chisato over here, Takina over here, they'll be happy because they can form a rectangle in this way, and there is no other point inside this rectangle. The other point is outside this rectangle. However, if Takina wants to be here, then that is not possible. It won't be a good arrangement because while we connect them in this way, Chisato at the top left, this is the top left, Takina in the bottom right, we will see that there is some other point inside. That is not possible. So, Chisato and Takina want to be placed in such a way, you have to assign them the pair of points in such a way that Chisato will be in the top left, Takina in the bottom right, and in the rectangle that is formed between them, there is no other point. There is no other point, even not on the rectangle that is given in the question. So, inside the fence and on the fence, none of them should happen. Otherwise, Chisato will be sad. So, all other points can be outside. They shouldn't be inside. And now the question is, how many possible ways are there? So in this diagram, if we see, Chisato and Takina can choose this rectangle. Chisato over here, Takina over here. Or Chisato and Takina can choose this particular rectangle. Sorry for my crazy drawing. Chisato over here, Takina over here. In this way they can rest. What is the other rectangle possible? Other rectangle is this one. So 3C2 rectangles are possible. 3C2 is 3. Yeah. This rectangle also, but over here if we place Chasito over here, Takina over here, that is not a good arrangement because the third point is inside this rectangle. That is not allowed. But in the other case, if you see, in the other cases, green and yellow cases, you can see that the third point is outside the rectangles. So both of them are good arrangements. So in this way, you have to say how many pairs of points are possible. As I explained, after understanding the problem through these lines, you might miss something, so you should always look at all the test cases. And after that, you should definitely check what are the constraints. Mostly people prefer checking that. So n goes up to 1000, which means, well, n square is fine, n square log n totally fine, n square root n a bit on the line, n cube no. With very less constraints, n cube still might be possible, but the constraints have to be, the constant elements have to be very less, so that the entire thing is within 10 to the power 8 or something like that. So how to actually solve this. Coming back over here, if I have to use the brute force, which you already have in problem number 2, that is like check every pair. Check every point that, hey, okay, we have a pair of points. Take the uh, top left and bottom right of them. See whether they can form a top left and bottom right. It's not always necessary that they would form. For example, if you have this kind of a, if this is a point, sorry, if this is a point and if this is another point at 1, 1 and 2, 2, you can't make one of them top left and another one bottom right. So if you have to form a rectangle here, the rectangle will look like this, and then it will be bottom left and top right. So not always every pair will even give you a possibility. So you should be able to, for every pair of points, you should check that, okay, top left basically means that this, if I call this as I and this one as J, then basically Xi is less than equal to Xj and Yi is greater than equal to Yj. So Chisato, or what was the name? Chisato should have a lesser X and a greater Y. That's it. Okay. Now the next point is, what if I go pairwise? If I go pairwise for every I and j, not only I have to check that if this thing is valid, if xi, xj and yi, yj, this comparison is valid, I have to check all the other points. Hey, are you falling in this rectangle? I have to check all the other points. Hey, are you falling in this rectangle or on the border? All the other points, which means n point checking for each pair. For each pair, I have to check n minus 2 other points for each pair of points, which means n square for number of pairs multiplied by other n minus 2 pairs. So n square into n minus 2 is n cube. And n cube will basically shoot past your allowed time complexity. This is too much. So we will keep brute force only for problem 2. Those are easy things. How will we optimize it? So, is big O n square allowed? Yes. So if big O n square is allowed, that means every pair you can deal with that individually. You can deal with every pair individually, but for a single pair you should not spend much time. But there are n square pairs, or big O n square pairs, NC2 pairs. You can spend some time on each of them, not too much time on any of them. It can be big O 1 time on each of them, maximum big O log n time. Okay, now given 2 points, how can you suddenly summarize what are the points inside them? That is not possible. What else can be possible? When you have to basically say, hey, I want between I and j, which points are you interested in? Between I and j, whether there are any anomalous points which will fall in between them and make us discard that pair. What is the possibility? The possibility basically would be if those points lie in this particular range, right? So if I have a prior list of things that they are in this range, that helps me. Let us go step by step. For this, for identifying which one will be Chisato and which one would be Takino, the first thing that I can do is, hey, I know this. So I can say that for all I, for each I, consider each j which is to the right of that I, correct or not? So for every I, I'll consider only those j which are to the right of that I, right? So if I have a different diagram like this, one question might arise that, hey, can I have for the single, what is that name, Chisato, can I have multiple Takinos? So yes, you can have one rectangle formed here, and for the same green body, you can have another possibility of Takino here. Both are valid rectangles. If you see this point and if you see this point, both are valid rectangles. This green would be happy to pair with both of them. So yes, multiple solutions are possible. But one thing is clear, that the green has to be to the left of this yellow and purple. Left or at the same point. So what can I say? The first thing that I can say is, okay, for each I, if I want to consider each j, that is such that xj is greater than equal to xi. This is done. If we know this, can we say it is prudent to sort all the points by the x values? If I sort all the points, that means for every point, all the points to its right are present to the right in the array. If I sort an array of points by the x value, then can I say whatever points come later in the array, they are to the right in the graph? That's exactly what I want. So basically, I can say for an I can basically say that for some I, you can basically search the Takino position in this particular range I plus 1 to n minus 1. That's it. Now, the next point is, so sorting will help you. But that we could have checked also, that for every I check which points I have greater. Let us see for which point what information I need. Let me draw a few more points to get clarity on that. Let us say we have a point here, and let us say we have a point here, then let us say we have a point here, and we have a point here, something like that. Let's say we have a point here. Okay. Now, for this guy, what do I need? No points are relevant. For this guy, this is only relevant, these 2 points. I don't have to look at any other point. Why? Because they are not lying, no point is lying inside. Well, for this point, I need to be careful. I need to look at, okay, between these 2 points, there is 1 point. So I should check where that is. Is that inside the rectangle or outside the rectangle? For this point, I can say that we need to check what lies between these 2 points, where this guy comes as well as this guy comes. Similarly, if I look at this particular point, I need to check, okay, between this and this, what are the points that come. So somewhere, for this Chisato, I have to consider so many positions for Takino, and for every such position for Takino, let me call it endpoint. Start point, which is Chisato's point, and end point. For every endpoint, I basically have to consider that in this horizontal part, in this range which you can visualize horizontally, in this range, are there any points? Or whichever points are there, do they lie inside this rectangle? For this guy, I don't have to see all of them. I just have to look at these things. So what can I say? I can basically say, hey, if I sort by the x values, what is the advantage? Do I have any advantage? Let us see. If I sort by the x values, then after this guy comes. At 2, 2, this guy comes. What will it do? It will say, hey, after you I have come directly, no intermediate point. So take me directly. Done. The next guy, so this has been taken. The next guy, when it comes, it basically says, hey, I want to come, I'm to your right, that is already checked by sorting. Now, if you want to take me, what are the hurdles? There is only one hurdle. This yellow part tells me there is only one hurdle. This yellow point over here, I'll just check according to that yellow point. And I'm done. And I say, okay, this is a valid thing. So you can introduce it. So basically, this also gets introduced. This point also gets introduced. Next point comes. Next point asks, hey, now before me, those 2 elements that have come, do they interfere when I want to be with you? No. Those 2 points don't interfere. These 2 points won't interfere. So once again, this also comes in. For the next point, I can say these 3 points are relevant. Can you see? So as we are moving from left to right, our points are building up. So when I'm moving from left to right, one point says, what items have I come across? Those only are risk to me. What are to my right, they are not risk to me. This guy is confident that points to its right are not relevant. Points to its right are outside. They are not relevant. So it is only focusing on the points to its left. And how can we isolate the points to its right and points to its left? Through that sorted mechanism. The moment we have sorted by the x value, we have automatically created this opportunity for us. Okay? So we can basically say whenever you go to a jth point, for every I you have to go to I plus 1 and I plus 2 and so on. When you go to some j, the j will basically tell you, hey, from I plus 1 to j minus 1, you have already come across those values. Based on what you have seen, do you think those could have come inside the rectangle? That is the question that we should ask. That okay, the moment we come to j, whenever we are coming to j, we should ask, hey, from I plus 1 to j minus 1, whatever points we have seen, do they fall inside rectangle? How can I guarantee? How can I check whether any of them falls inside this rectangle or not? Again, logically. So I can just store the relevant information. I can store the relevant information as I'm moving forward. When I moved through I plus 1, I plus 2 up to j minus 1, I'll store just the relevant information. How to prove this falls inside rectangle or not? Are my x values relevant? When I'm going to this point, whatever values I've come past here, are their x values important? No. I know that their x values are between this and this. So the x values are not important. What are important then? Their y values between this line and this line. Are they going to lie or not? That is what is important. Are they going to lie in this particular part or not? That's it. If they're going to lie, you're done. If any of them is going to lie, you are done. Now, how can you actually figure out, how can you maintain this information? If there is anything above this line, you can straight away ignore. You don't need to store anything in that case. And out of all the other points that are lying on or below this line, can I say just store the point with the maximum height? So, can I say below this, whatever points are there, I'm interested in the point with the maximum height. That has the highest chance of falling in my rectangle. If I say this rectangle, in this rectangle, the point with the highest height has the biggest chance of occurring in my rectangle. So I can say, hey, just record your heights or record your distance, y coordinate, basically. And whatever is the maximum y coordinate, but under or on this line, this particular line. Above this line, I'm not interested. Even if there is a point, that doesn't matter. The moment we have chosen the I over here, whatever later comes, which is above this line, doesn't matter for that I and some other later point. If that I is the starting point, top left point, then whatever occurs above that doesn't matter, because the rectangle will always have that as the topmost edge. This as the topmost edge. So I'll ignore all of them, and among the rest that are lying in this particular place, in this particular whatever points are lying, I'll say, hey, just maintain your topmost point. That is sufficient to tell me what is the maximum, whether that can lie inside. So yeah, that is it. Finally, you can just keep on counting. So let's take a quick look at the code. Okay, this is how I have sorted. This is how I've sorted. This is comparator sort. I'm sorting by A and then by B. This is an interesting thing that I did. So first I'm sorting in ascending order of x values. Then I'm sorting in descending order of y values. Why? Why am I sorting in descending order of y values? Because if there are 2 points, let's say I chose a Chisayu over here and there are 2 points over here. Which one can really help me out? You can actually put any of them probably, but I know that this one should be selected first. This one should be selected first. This deserves to be chosen, and this will never be chosen because this will lie in its line. This will lie inside the rectangle that this guy is going to try. So this will be of no help. That's why I have basically given preference to the higher j. This has a higher j, and hence this will be chosen. So I've sorted. This is the comparator sort basic code. What have I done? That this is the constructor, and then I've said that hey, if a is different, then a minus p dot a. So if a is lesser, then select this. Select the first element, and otherwise select the next element. This is how this compare to logic works. Otherwise, return in the other way. P dot b minus b. That is this is the other way. So pair P is basically as if an object is saying, hey, am I smaller than P or am I greater than P? And I'm saying, okay, this depends on whether your A is smaller than P is A or your B is greater than P is B. So that's why. And if this is a number less than 0, then we basically conclude that current element is less than p, and if this sum is greater than 0, then we conclude that it is greater than. Okay, now coming back, I'm going to just implement this using this pair class, where I have added it through this interface, comparable interface, and this is the standard compare to function which I am overriding. Next, what am I doing? I'm creating these pairs and sorting it simple up to here, and then just for every I, I'm going through every j. This is what the program is. So it's not a difficult code at all. For every I, I'm going through all the j's from I plus 1 to n. Then I'm saying, hey, can I form a rectangle with you? That is my first question. So max j is that thing which is storing the maximum j value of the elements which are lying in between, such that j is below that top line. So that is my max j. So I'm checking, hey, are you above that max j? That is important. If you're above that max j, then I'll consider. And if you are below myself, below the pi dot b, GSIU has to be above or at the same level. That same level thing is mentioned over here somewhere. It can be a line. You can see it can be a line. It may not be any area. So that means, yeah, it can be less than or equal. You have to be very careful about this nitty gritty. Less than, equal, or lesser, and so on. So if these two conditions are matching, then count plus plus. This basically means that the new point is lying below the starting point, and no other intermediate points are actually above the new points or the j points y coordinate. They are not above the j point. So then I'll increase the count, and then after that I will include this j point also in my max j. I will say if your j point is below the line, then include it in the max j. Max j is equal to the maximum of the max j and the this particular current point's y coordinate. That's it. Finally I will return the count. So you can see this an easy code. You just have to think about sorting. You just have to put the correct things, join the pieces in the right way. That's it. So most of the problems, you should actually target this to solve things in the easiest way, because only when you can solve things in the easy way, then only you have internalized the problem. Then only you have a confidence to solve all kinds of problems of similar level, of similar topics. That's it. Let me know if you have some further easier way of solving this problem. I'm sure these can be tweaked to form many variations we can solve in a variety of ways. But yeah, that's it. I hope you like the videos and the playlist. Please solve the contest or the problems if you haven't solved them yet. And please share your likes, subscribes, and let me know in the comments how you felt. Please share with folks who might find this informative. And all the best for your placement preparations, interview preparations, and everything. Thank you. Take care.